Excellent. Our next speaker is talking about NiCHART, a software suite to translate neuroimaging big data to individualized biomarkers in disease. And that's Feng-Li Hu, and he's from the Penn Statistics in Imaging and Visualization Endeavor, the PENSIV lab, from the University of Pennsylvania.
Hi, everyone. Today, I'm so excited to be here and share with you some exciting new software development that's going on at Penn. And this software is called NiCHART, and it is a neuroimaging chart for AI-based imaging biomarkers. And this is a comprehensive ecosystem for pre-processing and getting AI biomarkers. And I'm so excited to share that with you. Hopefully, by the end of this talk, you'll not only learn a little more about what NiCHART is, but also be as excited to try it out for yourselves as we are to develop it. How do I go next slide? Oh, mouse. There we go. No? There we go. Yes. So as we all know, neuroimaging is really hard to get into. I know that when I first started doing neuroimaging, I had to learn all these software packages and had to learn all these scientific and clinical knowledge, keep up with all this constant methods innovation, learn about validation, reproducibility, develop all these statistical and computational skills. Also have to purchase and have access to immense computational resources and have the data to run all these models on. And this is even more challenging with the growth of AI. Neuroimagers, new and old alike and experienced alike, we know that when we go to new modalities or have to learn new languages or learn new AI tools, that's an immense challenge, and that's exactly what NiCHART wants to overcome. So our hope for NiCHART is to abstract away some of these major challenges and leave behind just a few of these scientific questions behind so that you all, neuroimagers, can focus on the scientific and clinical knowledge and on the validation and reproducibility and leave the rest to us. And so what NiCHART is it's a comprehensive ecosystem that allows us to process multimodal MRI images, harmonize these to a reference data set, apply machine learning models that have been validated in large data sets, and contextualize these multimodal MRI images and the machine learning models in the context of a large reference population. So this is the overview of NiCHART. NiCHART consists of three components: image processing component, data harmonization, and machine learning. And what this means is that in the image processing, we have methods for fast segmentation, so fast ways to get intracranial volumes, Muse atlases, and white matter lesion segmentations in real time. We also have structural covariance pattern extractions using non-negative matrix factorization, as well as fMRI and DTI processing that has been well validated, previously published, stuff that is included in an automated pipeline. For data harmonization, we use state-of-the-art combat family methods, which provides a unifying framework of harmonization across a large set of papers in the linear model framework. And finally, we have our set of machine learning AI-based biomarkers. And this includes supervised models for both age and disease, as well as semi-supervised models for clustering in disease subtypes, and normative modeling to contextualize all of these features and biomarkers in a larger reference population. And behind all three of these components, we have our NiCHART reference dataset, which feeds into all three. So what exactly is our NiCHART reference dataset? Well, it's over 70,000 multimodal MRIs aggregated across 23 studies. And even now, we are constantly working on including more and more datasets into this framework so that we can get the most up-to-date reference models that we can. So these are all the models that we have in our, all the datasets that we have in our NiCHART framework. And this is the training data for our fast deep learning image processing. This is our reference population for pre-trained harmonization so that any new data is automatically harmonized to this large reference population. This is our training data and our fine-tuning data for all our ML metrics that have been previously published on smaller data sets and now have been rerun and improved on our NiCHART reference data set. And finally, for the purpose of contextualizing your images and your subjects, this is our reference population for normative modeling so that you can understand how abnormal your subjects are. So to talk a little more about our image processing component, here we have some of the structural analysis pipelines. So DLICV is fast, real-time intracranial volumes developed by training deep learning models on state-of-the-art statistical methods. We also have the Muse Atlas, which is a multi-label atlas method, again, using deep learning to improve the speed and efficiency of that. And finally, we have white matter lesion segmentations, again, using deep learning so that you can identify hyperintense lesions in white matter quickly and in real time. We also have SOP NMF, which stands for structurally orthogonal projection non-negative matrix factorization, which allows us to obtain these structural covariance networks that can reveal how patterns of structural data vary across the brain. Oops. We also have methods for DTI. So this is a comprehensive DTI analysis with QSI prep. Again, this is previously published methods, and we've just included this for your convenience and to obtain the imaging features that we need for later deep learning models. And finally, we have fMRI. We include fMRI prep and XCP D analyses, which is an end-to-end fMRI pre-processing and post-processing pipeline. And these also feed directly into PNet or RONet, which provides personalized functional connectivity networks. Once all this pre-processing is done, we know that there's a large amount of batch effects that happen in imaging data across scanners, across sites, and so on. And so we also have included an automated feature-wise harmonization method with unified combat family. And so this is combat GAM, COVBAT, all the standard combats, longitudinal combat, all of that unified in a common framework called combat family. And we've also included interactive diagnostics so that you can analyze whether the batch effects have been appropriately removed in your data set in a very convenient and easy to use way. And then finally, the most exciting part of NiCHART, at least to me, we have a number of AI-based biomarkers. These are things that, again, have been previously published, but as we all know, using these methods can often be challenging, especially if we have limited AI and ML experience. And so in the context of Alzheimer's disease, we have our SPARE-AD models, which identify different imaging signatures to predict whether a subject has Alzheimer's. And this is actually also associated with brain age, and so we've developed methods to disentangle brain aging, standard brain aging, from Alzheimer's disease in imaging signatures. We also have SmileGAN and SurrealGAN included in this, and these are semi-supervised methods for Alzheimer's disease clustering. And so we can see here there might be different subtypes of Alzheimer's disease, different presentations in different parts of the brain. And that's something that we have teased out with SmileGAN and SurrealGAN and included in our NiCHART biomarker set. In the context of other diseases, such as cardiovascular and metabolic diseases, we have our SPARE CVM. And we can actually see here that different metrics of SPARE CVM correlate with different diseases. And so this is imaging signatures in the brain that can be correlated with other biomarkers across the body. And finally, in NiCHART, we've included a gene scan, and this is a method for imaging and genetic joint biomarkers in both Alzheimer's and CVM. And so what this means is that you can upload SNPs as well as images and get these really nice biomarkers for your own subjects. And then finally, as an added component, we have normative modeling. So this is interactive visualization of user data contextualized by reference population centiles. And this is included for any imaging metrics extracted by NiCHART, as well as AI-based biomarkers. And so what this lets you do is upload your own data and see, oh, my subject is the 99th percentile for SPARE-AD, and maybe that's something that you are interested in. So this is our NiCHART framework. For the user, you just simply upload your images. It passes through our GUI. It passes through our API. We automatically perform harmonization, data validation, brain chart calculations, and you get back this really nice table of analysis-ready data, your anatomical masks, your brain volumes, all of your harmonization interactive diagnostics, and your AI-based biomarkers. So we invite you to analyze your data on our NiCHART cloud or run NiCHART locally. We hope to pay a little more for our AWS bill than we currently are. We're excited for you to compare your results to our population. We want to hear from you and want to know what features you want us to include as we're currently developing NiCHART. And eventually, we're super excited for you all to contribute your models to the NiCHART ecosystem, your AI biomarkers, and optimize them with our reference population. And in the NiCHART cloud, all of the uploaded data is privacy protected by AWS, so you can upload your data without any concerns. So I hope that you are as excited to try out NiCHART as I am to share this with you. This is our huge team that's worked on it so far. Yeah, I invite you to upload a few hundred nifties and see what our real-time analysis can do for your data and help you contextualize that in our reference population.
Thank you. Thanks a lot. That's a very impressive work. There is a couple of questions. I don't know if anyone has a question in the room. Yes, maybe. Go ahead.
Hello, nice work. Just wonder, you say you have a new segmentation tools for partialization, and then you use fMRI prep, which normally starts with free surfer. So did you change fMRI prep to take your segmentation, or you stay with free surfer ones?
Yeah, so I believe fMRI prep and the other preprocessing stuff starts with the original data, the same way that they run in standard use. We've just provided DL-ICV, DL-Muse, and DL white matter lesion segmentation as fast structural analysis, because usually this takes multiple hours. And actually, that's a very important question, because fMRI prep and XCP analysis and QSI prep take much longer to run. And so those are still things that take that same amount of time. We don't have fast methods for those yet.
You didn't change it?
Yeah, so those are identical, yes.
And maybe one quick question from the app is how easy to actually push a new pipeline to the system? And maybe also how easy is it to include a new data set to NiCHART?
So how easy is it to push a new
pipeline?
Oh, I guess two answers. We aren't too sure yet because we haven't actually implemented that in our software. But we do have contribution guidelines, and so as long as your method meets our contribution guidelines, aka takes sort of data sets or data tables that we offer and spits back outputs that we are familiar with, then it should be pretty easy to implement that ourselves. We're still working on automated ways to do that, but currently, if you get in contact with us, we can work with you to implement that manually.
Thanks a lot.